I want to make a supplemental video to the video I made earlier about similar solids to help you kind of know more specifically how to address some of the problems in the assignment. So let's suppose we have these two sets of solids here, A and B. First thing we want to be able to do is determine whether or not they're similar. So in other words, do they have the same ratios corresponding for the corresponding parts? So if you look at this, for example, for this first one, I take 3 over 6, that's 1/2, okay? That's that ratio. Now, all of these ratios of the corresponding little edges here have to be the same. So then I take 2 over 4, okay? So far, so good, that's 1/2. But then I have this 2 over 2. Well, 2 over 2 is equal to 1. That's not 1/2. Therefore, this one right here is not similar. Now, I come over here to this next one, and I notice I've got 3 over 6. That's 1/2. I've got 2 over 4 is 1/2. And then 2 over 4 again, 1/2. All those have the same ratio. That's 1/2. Okay. So now what we want to do is we want to compare. So this one, these are similar because they have the same ratio. And remember what we're doing. We're lining up the corresponding edges. This edge here, we match it up with that one, with this one, and so forth. Now I want to compare the surface area and the volume of these. So here's what we're going to do. Notice that the scale factor is 1/2. Now I want to calculate, first of all, for B, I want to calculate this smaller one. Okay, I'm going to calculate the smaller surface area first of all. Now you notice we've got the area of the top and the bottom. That's 6 and 6, that's 12. So there's the area of the base, the top and the bottom, right? And then we've got a couple of sides here. We've got 2 times 3 and 2 times 3. So that's going to be another 12. See, so I've got a 12. And then we've got these sides here, which is 2 times 2 is 4, so we've got 8 of those. So if you look at this, this is going to be 32 for the surface area. And all I did was just calculate, the area of those faces. Now, here's what we have. We have the volume, or the surface area of this smaller one is 32. That's going to be proportional to, let me just call it X. That's going to be proportional to the larger surface area. And that proportionality for the surface area is going to be 1 squared over 2 squared. See, the ratio here was 1 to 2. So the ratio of our surface area is going to be 1 squared over 2 squared. That's going to be the ratio. So if you look at this and solve for X, you get X equals 4 times 32. And that is going to be 128. So remember, we just said it, if the ratio is 1 to 2, then the ratio of the surface area is going to be 1 squared over 2 squared. Okay? If the ratio is A to B, it's going to be A squared over B squared. Now let's look at the volume. Okay? So this is the larger here. Now let's look at the volume. So this is the surface area. The surface area. Now let's look at the volume. So we're gonna look at the smaller. Okay? Now the smaller volume is going to be 2 times 3 times 2, right? See? It's just the area of the bottom times the height. So 2 times 3 times 2. So that's going to be 6, and times 2 is 12. Now, we go the same way. Now we're going to look at the larger. We've got 12 is to x, which I'm calling x just the volume of the larger, is equal to 1 cubed over 2 cubed. See? A cubed over B cubed. That's for the volume. So how we get from the smaller to the larger, it's going to be this factor here, whatever it is, the numerator cubed over the denominator cubed. Just like with the surface area, it was the numerator squared over the denominator squared. Now, let's see what we've got here. We've got x is equal to 8 times 12, which is 96. Okay, so this is the volume of the larger. So it doesn't matter what this ratio is. You find the volume or the surface area of the one, and then you set it equal. You set up the proportions.